So, you talked about absolute value in geometry as something being the distance away from 0. So that's what absolute value technically is. Our algebraic definition of absolute value is such. So this is all algebra lingo. I'll explain what it means in words here in a second. I'll give you a second to get it written down so you can comprehend what is coming out of my mouth. Okay. So in geometry, we're more concerned about the distance aspect of absolute value. But when we're doing it in algebra, I'm really just concerned about what happens when I take something, the absolute value of that something. Well, it becomes a positive, right? Like Bree said, it's always going to be a positive. So now let's wrap our brains around what's happening. If x is greater than or equal to 0, so what does that mean? What values is x going to be? All positives, including 0, right? If I take the absolute value of any positive number, it's going to come out to be the same exact number. Yes? Yeah. So that's what this statement is saying. So if you have a positive number or 0, because it's also true for 0, when you take the absolute value of it, it's going to be that number, right? The absolute value of 3 is 3. The absolute value of 4 is 4. The absolute value of 0 is 0. Okay? If x is less than 0, meaning it's what type of numbers?
Negative.
Negatives. When you take the absolute value of it, it's going to be the opposite of what it is, or the negative of it. And what's the negative of a negative?
Positive.
A positive. So the absolute value of negative 3 is the negative of negative 3, which is positive 3. Right? So we're thinking double negatives, which gets a little crazy. The absolute value of negative 4 is the negative of negative 4. And the reason why we need to remember this is because I'm going to end up with 2 solutions. I'm going to end up with 2 points on my graph for the same thing as your solutions. So when you go to make your solutions, you're going to have a positive version and you're going to have a negative version. So here is our first equation. So we have the absolute value of 2y minus 4 equals 12. Now, keeping in mind, we're going to have 2 solutions. I need to both have my positive number represented, and I need to have my negative number represented. So I'm going to create 2 separate equations. The first one's really easy. You just rewrite it without the absolute value sign. So 2y minus 4 is equal to 12. And I will tell you this. You guys learned this in Algebra 1. We do it again in Algebra 2. Next year, if you take a math class, whether it's advanced algebra or pre-calculus, there will still be people making the same mistake. They will only solve this one equation, and they don't solve the negative version. I don't know why no one ever remembers to do this. What I like to think of is these kind of look like Roman numeral 2s. So I need to have 2s, or sometimes I'll like branch it out off of one, like, oh, that has to be my positive. Oh, that needs to be my negative, or something like that. Okay, so I got my positive version. Now let's make our negative version. Everything that's inside the absolute value sign stays the same. But now I want to make it equal to negative 12. Because this is what I'm saying. I want whatever 2y minus 4 is to be 12 units away. So I want this distance to be 12 units away. Well, what's 12 units away from 0? Positive 12. But negative 12 is also 12 units away from 0. So that's why I'm going to use a negative 12. Can we solve these 2 equations? Yes, hopefully. Go ahead and beat me to the end. Add 4, 2y equals 16, divide 2, get y is equal to 8, add 4, add 4, 2y equals negative 8. I feel like I'm going fast because I feel like this is children's play for you right now. And we get y is equal to negative 4. You guys in agreement? Now how do we write our answers? Can my solution be both 8 and negative 4 at the same time? Like, in my mind, I see them battling. Like, I see 8 here and the negative 4. No, no, I want to go in for y. I want to go in for y. No, me. Is there any way that they're going to be there at the same time?
No.
No.
Because they want to go away to y.
Yes. So we have to put an or. You were right, Cole. So for our answer, we're going to say y. Usually put the smallest one first. Negative 4 or 8. Okay. They can't be it at the same time. It's either one or the other. Can't be both at the same time. It doesn't work that way. Okay?
So the absolute sign doesn't even really matter. You just have to...
The only thing the absolute value sign is telling me is that I need to have both the positive and the negative version. Yeah. Okay?
Yeah.
So once, you don't do this if you don't have the absolute value sign. If the absolute value sign wasn't there, then I would just solve it normally. Okay? All right, let's do another one. So we have 3 times the absolute value of 4w minus 1. And then outside of the absolute value is a minus 5 equals 10. What's different about this problem than the last problem?
It has a 3 outside the square.
And what else?
And there's a negative 5.
Yeah, and a negative 5. So before you can split into your 2 equations, you have to get the absolute sign all by itself. This is incorrect. Watch, don't do this. If you would do 3 times 4w minus 1 minus 5 is equal to 10, that would get you half of the answer right. But if you did the same thing, better not be writing this because it's not correct. You'll be wasting lead. And if you make it to a negative 10, that's not going to get you to the right answer. So you can't do it right away. We have to get the absolute value sign by itself first. So to do that, let's get rid of the 5. Move the 5 over by doing what?
Plus 5.
Yep, so let's add 5 over. Yeah, Ben Driscoll's on top of this stuff today. Then we're going to do what? Divide by 3. Now we have the absolute value sign all by itself. I'll take the easy one. I'll do the positive version. 4w minus 1 equals 5. What's the other half?
4w minus 1 equals negative 5.
There it is. Finish it up. 2-step equations. Fractions are friends, just reduce them. You get w to equal negative 1 or 3/2. That's what you should have gotten to. Yes. Yeah, sign up. Okay. I'm going to show you your favorite type of absolute value equation. Are you ready?
Nope.
This is going to become your favorite one.
I like it already.
The absolute value of w minus 5 equals negative 8. Someone tell me why this would be my favorite one. It's what?
It's already negative?
Well, I do want to focus on that negative, but what specifically about it? Think of our graph. Remember before, if we had it equal to 3, I'm looking for my y value where it's 3. Right now it's equaling 8. Will I ever have an absolute value graph down here at negative 8?
No.
Is there any way I can take an absolute value of any number and get it to be a -8?
No.
So if I don't have anything, what do we say?
Can't do it.
We don't say can't do it.
No solution.
No solution. Or undefined means the same thing. Okay, so you can either use the symbol or write the words.
So if the answer like is a negative, you can't.
Yeah, there's no way we can possibly take an absolute value. Because didn't you say, Mr. Gronke told me it's always going to be positive, right? You did. So if this is telling me, well, tell me what W has to be for it to be -8, well, there's no possible way that I could do it. Okay? So those are going to be your favorite ones. So you don't have to do any work when you see that negative. All right, so we've got equations. Are we ready for inequalities?
No. Forgot there was that part.
All right, how about we do this? How about we save inequalities for next class? Because I feel like if I try to cram it into